because this defines a factorial function, and that one also s plus 1 minus t into s plus 2 minus t, all divided by 2 minus t into 3 minus t, 1 multiplied by 2 a naught. So which now gives A2 equals r plus 1 minus t sub 2 into s plus 1 minus t sub 2 divided by 2 minus t sub 2 factorial a naught. Now, following the same line of argument with the previous solution, I can generalize from this point that if we continue, this becomes ak equals r plus 1 minus t sub k, s plus 1 minus t sub k divided by 2 minus t sub k, k factorial a naught. We now go back to equation 2, which was our trial solution. Now recall, y equals summation n from 0 to infinity a n x raised to power n plus c. Now, we substitute the value of our initial root 1 minus t into this, so that becomes, put c equals to 1 minus t will give us, implies that y equals x raised to power 1 minus t summation n from 0 to infinity a n x raised to power n. We follow the same pattern with the previous solution, that is the first solution. So we expand that and make necessary substitution. By expanding this and make necessary solution, we are going to have y equals a naught, y equals x raised to power 1 minus t into a naught plus summation k from 1 to infinity of r plus 1 minus t sub k, s plus 1 minus t sub k divided by 2 minus t sub k, k factorial a naught x raised to power k, which now gives a naught x raised to power 1 minus t summation k from 0 to infinity r plus 1 minus t sub k, s plus 1 minus t sub k divided by 2 minus t sub k, k factorial x raised to power k, which is the second solution. In hypergeometric function form, we write y2 now, a naught x raised to power 1 minus t summation, f of r plus 1 minus t, comma, s plus 1 minus t, semicolon, 2 minus t, semicolon, x. And that gives the second solution. So far, we have considered hypergeometric equation as a special equation with special solution. The two solutions of hypergeometric equation are referred to as hypergeometric function after solving using Frobenius method. So how do we apply this? Let us take one or two mathematical examples to illustrate this solution. Examples. grab off the whole of this. Example. Express the solutions of the following differential equations in terms of f a comma b semicolon c semicolon x. A 2x 1 minus x y prime prime plus 1 minus x y prime plus 3y is 0. B x into 1 minus x y prime prime minus 3y prime plus 2y is 0. C x minus x squared y prime prime plus 3 divided by 2 minus 2xy prime plus 2y equals to 0. And lastly, 8x 1 minus x y prime prime plus 4 minus 14x y prime minus y equals to 0. I will attempt A and B. I will leave C and D as exercise against our next class so that you keep yourself busy while we wait for the next class. So therefore, I will put what I refer to as STV, student to verify, against these two. While this, I put LTV here, that is the lecturer to verify. So I will solve the first two. Now, there are two ways to solving these problems. Number one is to start from the first principle. Now, as a matter of fact, anytime we use the first principle in mathematics, generally, it means start from beginning. Start from the definition. That's the meaning of first principle. So, I have already used first principle to establish the two results for hypergeometric equation. So what I will do here is just to compare each of these equations with the general form of hypergeometric equation and obtain those three parameters Rs and T. That's what we are going to do now. So as your assignment, what I'm about doing, try as much as possible to do that. Also, solve these two problems from the first principle and compare the two results. You are going to get an interesting result, and the two results will always be the same. So let's take the first one, solution. A, I have 2x 1 minus x y prime prime plus 1 minus x y prime plus 3y equals to 0. First thing here is to ensure that the coefficient here is 1. Because the general form of hypergeometric equation has the coefficient of this variable to be 1. So we divide all through by 2 so that we have x 1 minus x y prime prime plus half x over 2 y prime plus 3 over 2y equals to 0. Now compare. Let us compare with x 1 minus x y prime prime plus t minus r plus s plus 1 x y prime minus rsy equals to 0. By comparison, we will observe that t is half. We obtain our t. Our r plus s plus 1 is 1 over 2 also. And our rs Our RS is minus 3 over 2. So I need to solve these two equations to obtain the value of R and S respectively. How do we do that? From the first one, from here, we observe that make either R or S subject formula, that our S equals half equals minus half minus R. Substitute that one into this expression. We have R into minus half minus R equals minus 3 over 2. And what do we do from here? We have R squared after multiplying by negative all through plus 1 over 2R minus 3 over 2 equals to 0. We need to solve this quadratic equation. And what are the factors? Of course, the factors here will be 3 over 2 and minus 1. So I will have this one to be R plus 1 and then minus 1. I will have this one to be R minus 1 and R plus 3 over 2 equals 0. So that R is 1 or R is minus 3 over 2. You pick either of the two solutions because the two of them will give values for S. So let's see. When R is 1, the corresponding value of S here is minus 3 over 2, which is equivalent to what you have here. If you substitute minus 3 over 2 here, the corresponding value of S is 1. So either of the two can be used. So therefore, the first solution, our y1, which is summation R sub k S sub k divided by T sub k k from 0 to infinity. Our R is known, which is F R S semicolon T semicolon X. So finally, the first solution to that equation will give us our R. Let's take 1, F1, then our S corresponding to that minus 3 over 2 semicolon, our T half, then X. We can as well write it as minus 3 over 2 comma 1 semicolon half semicolon X. In our next class, we are going to establish the two results, that these two are the same. In our next class, we're going to establish that fact, and that property is what referred to as symmetric property of hypergeometric function. They are the same. So the second solution, the second solution to that equation will be y2, which is written as x to the power 1 minus t f r s r plus 1 minus t comma s plus 1 minus t semicolon 2 minus t semicolon x. So our t is half, so this becomes x is power half f into our r. We have considered r to be 1. So 1 plus 1 is 2. 2 minus half will give us 3 over 2 semicolon. We consider our s to be minus 3 over 2. Minus 3 over 2 plus 1 will give us a minus half. Minus half minus half give us minus 1 semicolon. 2 minus half will give us 3 over 2 semicolon x. That is the second solution. So let's take the second question. we'll solve it, then we'll draw the curtain for today's class. The second question is B, x into 1 minus x, y prime prime, minus 3y prime, plus 2y equals to 0. We compare this to x into 1 minus x, y prime prime plus bracket t minus r plus s plus 1, x y prime minus rsy equals to 0. So, through that, our t becomes minus 3, our r plus s plus 1, there is no x terms here, we don't have any x term here, so that becomes 0, and finally my rs is minus 2. That's what we have. So what do we do from this point? Like we did in the other one, we are going to solve those two equations simultaneously. And solving these two equations simultaneously, we are going to have r equals to minus 2 or r equals to 1. If you solve it simultaneously, that's what you are going to have. And the value of our s, because we can determine s from here. If r is minus 2, this is minus 1. So s, corresponding value of s there is 1. Or s equals to minus 2. So let us make our substitution. So the first solution is f, our r, minus 2, comma 1, semicolon, minus 3, semicolon x. The second solution is 1 minus t, that is x raised to power 4, f into r plus 1 minus 2 plus 1 is a minus 1 plus 3 to give us 2. The second one, which is a 1 plus 1, 2, that gives us 5, semicolon. Then I have 2 minus 3, which also gives 5, semicolon x. So this is where we are going to stop in today's class. Our next class, we shall continue our discussion on hypergeometric function. And the major focus of that class will be that how do we convert some known function, say arc sine x, ln 1 plus x, exponential x, to hypergeometric form. That will be the major focus of that class. Till we meet in that class, I am Abdelghani Redouane Online in Yoda. Thank you for your attention.